We are going to use the same data set, the irises data set that we used earlier in ANOVA. 3 species, but let's pick one. Which one should we pick? I don't think we should, well, you tell me, which one should we pick?
Well, which one do you want to pick? Because there's clearly the right answer or the wrong answer.
True.
So choose which one you want.
I mean, Sydney. Setosa.
Wrong.
That's not what I had in mind. I would pick either Versicolor or Virginica. Reason being, linear models depend on an assumption. Any thoughts as to what that assumption will be? The responses are normal. But responses in the sense, in our case, the petal length. So I am going to choose either Versicolor or Virginica. Which one do you want to pick? Okay, let's go for. I would have gone for the same. So both of those satisfy normality. So I can pick either, but let's pick Versicolor. A linear model. So a linear model is simply an equation that you are trying to come up with to find a connection between two variables. There is a name for that in statistics way back when, a relationship between two variables. Particularly, you are trying to come up with a linear relationship between the two. Omar. Okay, word game starts with the letter R, ends with N. Regression, very good. So we need linear regression. So if we are fitting a linear model of any kind, we call it linear regression. And before we proceed, one, we've got to check if the data is normal. Second, we have to identify our independent and dependent variable. Well, we have the species, which is Versicolor. I know one of the variables, petal length, and you need another variable to correlate with, associate with. What would you pick? If you pick a flower and you've got petal length and sepal length width, what should we compare? Think of a person. A simple linear regression example is you compare the height of a person to their weight. Yes, height versus weight to determine a correlation. Go ahead, Cleo. I can compare length to width. Is the petal length related to petal width in some way for the species that we chose? So our model that we are trying to fit, let's use petal length as the dependent variable, y, and petal width as x. Is there a different model that I can use? Yes, no, maybe. Within Versicolor, the species that I chose. There are other options. I can compare petal length to sepal length, petal length to sepal width, but all for the same species. I'm picking one of those three cases. If we want to fit a linear model, the data has to be linear, correct? Yes. Otherwise, it would be silly. There is a plot to determine if the data is linear. What is that plot? Very good. We have already determined that the data satisfies normality. I'm simply going to see if they are linearly correlated. So length is response, so I'll put it as y. X goes first, then y. So the X variable is width, specifically petal width. Y variable is petal length. And we are looking at Versicolor. And that is the data that we have. Do you think that it might be linear? Yes, no, maybe. Let me set the limits so that perhaps we'll have a better picture. X values, I'm going to go from 0 to 2. Y values, 0 to 6.
Yeah.
That's the data that I have. Do you think that perhaps it is linear? Maybe. It is possible. So, in 2023 basic stats, we found a value that will tell us the strength of linear correlation. Do we remember what that is? Going back to earlier today, you asked me why the language is called this letter. What is that letter? R.
Yes, R is an R.
That's all I want you to do.
Perfect.
I didn't want you to burden yourself too much.
Well, thanks.
You're welcome. I try. We want to determine the correlation between X and Y. X would be the petal width. and y petal length if there is correlation, we can fit a model the correlation is 0.78666666. Is it decent? Yeah, 78.66%. Good amount. So decent level of correlation. The pictures agree with the value.